Welcome to the class. Today topic is Rutherford nuclear model of an atom. Rutherford nuclear model of an atom. Okay, for this concept he has taken alpha particle source alpha particle source, okay, which is a radioactive material which can emit the radio alpha particles, okay, alpha particles from here. Then okay, there is a lead plate which has some hole, okay, lead plate, and then these are passed through the lead plate, and then they are projected on a gold foil. The gold foil means it is a gold plate, okay, say gold plate, okay. And then he observed okay, this is zinc sulfide screen, zinc sulfide coated ZNS coated screen, ZNS coated screen, okay, this is ZNS coated screen. Then most of the alpha particles are passed through this gold metal foil. This is gold metal foil, okay. Most of the what he observed is most of the alpha particles are come in this way, and they are goes to zinc sulfide screen straight away, okay. Most of the rays are passed through this gold foil, but a few are deflected, a few of them is deflected like this, okay, a few of them is deflected and most of the rays are passed through this, okay. And very few are come back, okay, opposite, they are come back in opposite direction, okay. This number is 1 out of 20,000 alpha rays, only 1 out of 20,000 alpha rays, one is come back, okay. From this experiment, what he observed is the observation 1, most of the alpha particles passed through the gold foil undeflected. We know most of the alpha particle pass through the gold foil undeflected. They go straight away, okay. They pass through the gold foil without any deflection. They go straight away, okay. Next point, he observed a small fraction of alpha particles was deflected by small angles, okay. They are deflected a small angles, okay. A small fraction of alpha particles, second point, alpha particles was deflected by small angles. Next, third observation, a very few, this number is very less, a few alpha particles bounce back, okay. Very few are bounce back, they are straight away bounce back, okay. These are the observations Rutherford is noticed, okay. Rutherford noticed these three observations. Then he conclude that most of the space in an atom was empty. Most of the space in an atom is empty. Okay, most of the most of the space in an atom is empty, as most of the alpha particle pass through the foil undeflected. Okay, most of the space in an atom is empty, as most of the alpha particle pass through the foil is undeflected. What it means? Atom, generally atom, what he conclude that most of the atom is empty. Okay, that is the reason why so many rays are passed through this, okay, without any deflection. Okay, because the most of the space is empty. Okay, most of the atom is empty. So only whenever a ray goes to this direction, only some of them are deflected like this. Only very few are bounce back. Very few are bounce back, because the nucleus is concentrated with a small area. It contains only small area. Remaining part of the atom is empty. So whenever an alpha ray comes to the atom, okay, they straight away goes to the out of the metal atom and strike on the zinc sulfide screen. Okay, they strike on the zinc sulfide screen. Okay, they simply strike on the zinc sulfide screen. Okay. Okay, only a few are deflected like this, and very few are comes back. Okay, what is the means of alpha particle? Alpha particle is helium 2 plus ion. This is known as alpha particle. Alpha particle contains positive charge. Okay, here nucleus contains positive charge. That is the reason why positive charge are repelled like this. They are deflected like this. And whenever a ray goes to straight away hit the ray, whenever they hit the nucleus is a positive charge. Okay, this is also positive charge. They straight away come back to the same direction in opposite way, in opposite direction. Okay, in opposite direction. Okay, this is the way Rutherford nuclear model has some other conclusions also present. Next conclusion is a few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force, showing that the positively charge of the atom is not spread throughout the atom as Thomson had presumed. The second point indicates, okay, most of the atom, okay, the positive charge, a few positively charged alpha particles are deflected. A few positive charged alpha particles are deflected. Deflection must be due to enormous repulsive force, showing that positive charge is not spread throughout the atom. Okay, according to Thomson model, the positive charge is spread throughout the atom. But here he concludes the positive charge only concentrated in smaller area. That is the reason why most of the rays are passed through this atom, but very few are deflected like this. Very few are deflected because the most of the atom does not contain the positive charge. Only small area contains the positive charge. That is the reason why most of the rays are passed through the atom, but only a few is deflected. Okay, this is against the Thomson model. Thomson model says that positive charge is spread throughout the atom, but here the positive charge is concentrated only a limited area. This is the difference between Rutherford and Thomson model. Next, the third point. Third point, the volume of the nucleus is negligible as compared to the total volume of the atom. We know the area of the nucleus is very small than compared to the total volume of the atom. So this is the third conclusion. Okay. Next, according to this model, based on that observations and these conclusions, he proposed a model. Okay, nuclear model. Okay, this is known as Rutherford nuclear atomic model. Rutherford nuclear atomic model. Okay, according to his theory, okay, he proposed a theory based on observations and conclusions. He made a theory. Okay, this theory says the positively charged and most of the mass of the atom is densely concentrated extremely small region. We know the mass of an atom is densely concentrated in smaller area. Most of the part is empty. The mass of an atom is only concentrated in smaller area. This is his theory. This is the first point of his theory. Positive charge and most of the mass of an atom is densely concentrated on the smaller region. That is known as nucleus. Okay, nucleus. In an atom, nucleus is alone has greater mass. Our mass of an atom is only concentrated in a smaller region. That is known as nucleus. Okay, next. Second point here, according to his theory, the nucleus is surrounded by electrons. Okay, that move around the nucleus with very high speed in circular path is called orbit. Orbits. Okay, nucleus is surrounded by the electron. According to his theory, nucleus is surrounded by electrons. Electrons are revolving around the nucleus. These circular paths are known as orbits. These are known as orbits. Okay, these circular paths are known as orbits. The nucleus is surrounded by electrons that move around the nucleus with very high speed. Circular paths is called as orbits. These circular paths are called orbits. Okay, this is also a orbit. This is a nucleus. Nucleus. This is also orbit. Okay, this is also orbit. This is also orbit. Okay, one orbit and another orbit. Next, electrons and nucleus are held together by electrostatic force of attraction. Nucleus is concentrated on the center of atom and electrons revolving around the nucleus. Okay, these two, nucleus has positive charge and this is negative charge. Electron revolving around the nucleus has negative charge. These two, okay, nucleus and electrons, both of them have the force of attraction is known as electrostatic force of attraction. Okay, electrons and the nucleus are held together by electrostatic force of attraction. These two together, electron and the nucleus are held together by electrostatic force of attraction. Electrostatic force of attraction. Due to electrostatic force of attraction, electron revolving around the nucleus in an orbit, these together held together by electrostatic force of attraction. Okay, held together by electrostatic force of attraction. Okay, next, what are the defects? Okay, first of all, he made an experiment and then the observations. He made some observations, 3 observations. From that observation, he concluded 3 points, and from the observations and the conclusions, he made a theory. Okay, first of all, he made an experiment, and from the experiment, some observations. Then, from the observations, he has concluded 3 conclusions. From the observation and conclusions, he made a theory. The theory says the 3 points. Okay, this theory says these 3 points. Okay, the theory is very simple. We know the most of the mass of an atom. First point, positive charge and most of the mass is concentrated on the nucleus. Nucleus is very small and electrons are revolving around the nucleus. This part is known as orbit. Okay, this is held to the third point is these two are held together by electrostatic force and attraction. This is the very simple theory. These three are the points on the Rutherford atomic model. Okay, these are the next one, drawbacks. What are the drawbacks are present in the according to his theory? Okay, drawbacks. Okay, of Rutherford model. What are the drawbacks are present in the Rutherford model? Is charged particle. According to the Maxwell theory, any charged particle revolving around the nucleus, they continuously emit the radiation and then fell into the nucleus. What? Okay, this is the concept Maxwell has proposed. Okay, this is the against to the Maxwell theory. This is against the Maxwell theory. Okay, according to the that theory, any particular object which is revolving, okay, accelerated and like electron like particles accelerated around the nucleus, they should lose energy. Any charged particle in revolving around the nucleus should lose its energy and then fell into the nucleus. Okay, then continuously fell into the nucleus. What the whole theory satisfies. Okay, but in this Rutherford cannot explain why this not happens here. Okay, we know this model. This model is similar to the planetary model. Okay, according to planetary model, sun is present in the center and planets are revolving around the sun. But the planets not fell into the sun core because the planets does not contain any charge. That is the reason why planets in the solar system, planets not fell into the sun, because in planetary system, planets, okay, does not contain any charge. But here the electron has a charge. Okay, any charged body on acceleration or are revolving around the nucleus, they should emit the radiation and then fell into the nucleus. So then atom is collapsed. Then whenever the electron goes to the nucleus, atom will be collapsed. So there is no atom. Then what is the meaning of the atomic model of the Rutherford? So this is the meaning. This is the way he cannot explain why charged particle accelerated should emit the electromagnetic radiation. Okay, then fell into the nucleus. The atom is unstable. So this type of questions he cannot answer. So this theory has a major drawback for this. Okay. Any charged particle when accelerated should emit the electromagnetic radiation. Therefore, an electron in an orbit will emit radiation. The orbit will continuously shrink and then collapse. Okay, this is the major drawback of the Rutherford model. This is the major drawback of the Rutherford model. Okay, this is about Rutherford model. But this question may not come to the examination. Okay, most of the time it may not appear in your examination intermediate. But this concept is essential for your understanding of the chemistry. Okay, concept is essential, but you may not expect the Rutherford model will appear during the annual examination. No, I cannot see this type of question will not appear in your annual examinations. But the concept is essential to understanding the atomic structure in better way. What is the first theory? What is the next theory? What is the another next theory? So in this way you can understand in better way. But the next theory is after this theory, Bohr model will come. So we saw two models. First, we know J. Thomson model, atomic model. Next one is Rutherford. This one is Rutherford atomic model. Next model will come. This is known as Bohr model. Okay. Next model, quantum mechanical model of an atom. These are the four models are present in the atomic structures. So these four models are the pillars of the development of the an atom. Okay, atomic structure, how is atoms exist. Okay, one by one you may understand. Okay, you may not expect this one will come. This is a 4-mark question or 6-mark question or 8-mark question. You may not expect. The theory is the important one. Okay, you must understand on that way. Okay, the concepts are essential concepts. Okay, how Rutherford drawback. What is the drawback? The Rutherford theory. Okay, this is the main theory. Then you can understand another theory. What is the best points in another theory? What is the lagging